Right now we're going to do 37 on page 6. So we just did the medians, okay, and now we're going to do a perpendicular bisector, which we kind of did in the other problem that had the 3 points and have to find the circle. It's the same math, but let's just do this, okay? So it's the same point, so that was -6 and 0, and 12 and 0, and 0 and 12. Okay, so that's the same triangle. And now we have to get a perpendicular bisector, so you have to get a midpoint, and have to get a slope that is perpendicular to this, and you have to find the intersection, and we have to show that it's equidistant by using the distance formula, and find the equation of the circle that can be circumscribed about the triangle. Okay, all right, so let's get the midpoint first. This is 6, 6. We already got in the other problem. This was 3 and 0, right? And this one was -3 and 6. Okay, if you don't know how to get this, watch the video for 36, because we got these points in the video already. Okay, now the slope here is -1, so this has to be 1. So this is going to go through origin because it's a 0 and 0, right? I mean 6 and 6. So this equation is y equal x. Okay, and this equation is y equal 3. I mean x equals 3, because it's perpendicular, so you have to be, the slope is undefined, and it's going to go through 3. So that's the other equation. And this one, the slope is 6 and 12, so that's 2. So this slope should be -1/2. So it should be -1/2 x plus b. And you have to go through this point, right? So this is the slope. It's perpendicular to the slope of 2. And you plug this in, this point that you have to go through, which is a midpoint. So 6 equal -1/2 times -3 plus b. So that's 6 equal 3/2 plus b. So b have to equal 6 minus 3/2, which is, this is 2/12 minus 3, so that's 9. Okay, so the equation is y equal -1/2 x plus 9/2. So those are the 3 equations. Okay, now we have to get the show the 3 perpendicular point, meet a point C. Now this one, where it meets, easiest to do is this, right? X equals 3, y equals 3, this is 3, 3. Okay, intersection is 3 and 3. Now, to check to see if that's gonna go through this point, you plug this point in here and see if equal holds, okay? So the 3 have to equal -1/2 times 3 plus 9/2. So that's -1, oh no, times 3, so 2/3 plus 9/2, so that's 2/6, which is 3. Okay, so it will go through that point. Okay, and what else do we have to do? You have to show that it's equidistant from this point. Okay, so show that C is equidistant from Q, R, and S. So you have to show that D is equidistant. Okay, so let's just see. This is Q, and this is R, and this is S, and this is called C. Okay, so let's do QC first. QC is square root of x is 6, so that's 9, so 81 plus 3, 9 equals square root of 90, which is 3√10. Okay, and then let's do RC. Square root of 3 to 12 is 9, so that's 81, and that's 9, so that's the same. 3√10, and then SC is the square root of 0 to 3, so that's 9, plus 12 to 3, that's 9, so that's 81. It is the same. Okay, so that's a B. This was A. Okay, and then what else we have to do? Find the equation of the circle that can be circumscribed. Okay, so the fact that this is as equidistant to these points, if you do a circumscribed circle, it's going to go through these 3 points, right? So this is the center of the circle. So the equation is going to have x minus 3 squared plus y minus 3 squared. And the radius is this, because we already calculated the distance. This should be radius, right? This is also radius. This is also radius. So square of this is square of this, right? So it should be 90, because this is radius. 9 times 10 is 90. So this is the equation. Okay.